Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. For a molecule to exist as enantiomers, it must possess a chiral center, stereocenter, a carbon bearing 4 different substituents. In an open-chain alkane, we need to find the minimum number of carbons required to create such a chiral center. Moving on to the next step. Identify what makes a chiral center in an alkane. A carbon in an alkane chain is chiral only if it bears 4 different groups. For an interior carbon in a straight or branched chain, the 4 substituents are 2 alkyl chains of different lengths and 2 hydrogens, but 2 H's means it cannot be chiral. So branching is required. Moving on to the next step. Consider branched alkanes. The smallest branched alkane with a potential chiral center is 2-methylalkanes. For a quaternary-like chiral carbon, with no H on the central carbon, we need a carbon connected to 4 different carbon-containing groups. And for the final step, the simplest case, consider 2-methylhexane, 7 carbons CH3CH, CH3, CH2, 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 CH3. The C2 carbon has CH3, CH3, H, and C4H9 chain, but 2 identical CH3 groups means not chiral. CH3, CH2, CH, CH3, CH2, CH2, CH3. The C3 carbon has ethyl, C2H5, methyl, CH3, propyl, C3H7, and H, 4 different groups. This is a chiral center. Check if 6 carbons suffice. 3-methylpentane, 6 carbons CH3, CH2, CH, CH3, CH2, CH3. C3 has ethyl, methyl, ethyl, H, 2 identical ethyl groups, so not chiral. All other 6 carbon branched alkanes similarly fail to produce 4 different substituents. Check 5 carbon alkanes. The only branched 5 carbon alkane is 2-methylbutane, isopentane CH3CH, CH3, CH2, CH3. C2 has 2 CH3 groups, not chiral. Number 5 carbon open chain alkane has a chiral center. Therefore, 7 carbons, specifically 3-methylhexane, is the minimum number of carbons needed for an open chain alkane to possess a chiral center and thus exist as enantiomers. Options A, 4, B, 5, and C, 6 are insufficient because no branched alkane with fewer than 7 carbons can bear a carbon with 4 distinct substituents. Therefore, the correct answer is D. Therefore, the correct answer is option D.